Hi everyone, this is Fahad Mirza and I welcome you to the channel. Things are moving fast. Alibaba has just released this model for emotion recognition. The model is a vision model with thinking. It is industry's first application of reinforcement learning with verifiable rewards to an Omni-multimodal LLMs. We already have covered few of the Omni models from different providers, and in this one, this emotion recognition model is something different because it tries to accomplish a task where both visual and audio modalities play crucial roles. To validate the potential of combining RLVR with Omni model, there are various key insights which this model offers, and I will describe them as we go. So we are going to install it locally and then we will try it out on few of the videos to see what sort of emotions it recognizes in a thinking mode. Before that, let me also introduce you to the sponsors of the video who are Mass Compute. If you're looking to rent a GPU or VM on very affordable prices, you can find the link to their website in video's description. This is the VM they are sponsoring, and this is the GPU card NVIDIA RTX A6000 with 48 GB of VRAM, being sponsored by our good friends at Mass Compute. Let me create a virtual environment with Conda and then we will start installing everything. That should be done any second now. That is done. Next up, let's git clone the repo. So this is based on this DeepSeek R1. So we have installed that one, and then from the root of the repo we need to run this bash setup.sh script, and this is going to take a few minutes, so let's wait. And while that happens, let me also introduce you to the sponsors of the video, who are Camel AI. Camel is an open source community focused on building multi-agent infrastructures for finding the scaling laws of agents with applications in data generation, task automation, and world simulation. All the prerequisites are done. Next up, we need to download the models, which are the auxiliary models, by the way. And for that, the models are this Google's SIGLIP one. SIGLIP is a multimodal model with a better loss function, and I have already covered it in other videos, so please check it out. And then we also need to download this Whisper Large V3 model, which is OpenAI's ASR or automatic speech recognition and speech translation model. So I already have downloaded these to my local system and I have placed them in separate directories, as you can see in a my model directory. If you don't know how to download them, let me show you the command. So all you need to do is to log into Hugging Face with Hugging Face CLI and then just issue this command where I am downloading this Whisper model to my local directory and I'm not using any symbolic links. As I already have run this, so I'm not going to run it again. But I do need to download this R1-Omni, the actual model. So for that, I have just created a new directory under my models. And then I'm going to run this command, Hugging Face CLI, to download this model here. And the model is being downloaded. It's not a huge model, just 2.75 gig. And the model is downloaded here. Next up, let's open this directory of this model in VS Code. And then we need to open this config.json from where you have downloaded the model, and then just go to this line number 23, and this is where we need to replace this path where we have downloaded our Whisper Large v3. So this is my path on operating system where I have downloaded this Whisper Large 3. So this one is for the speech. For the vision, we need to change this line number 31 vision tower path, and this will be to our SIGLIP. There you go. So I have replaced both of the models. They are pointing to the correct models locally, and that is all we needed to do. So I have saved it. Let's go back to our terminal. I'm just going to minimize this. Let's clear the screen, and now it's time to run the inference on our local video. So for the inference, what I'm going to do, I'm just going to play this video from my local system. It's just a casual video of me talking into a microphone. Okay, so let me stop it, and then in order to do the inference, they also have provided a script from the root of the repo. So I'll just go back, and then I'm just going to go into the directory. So if I do ls-ltr, you will see that there is a setup file, there is a source file. So if you do ls-ltr, even in the source one, you won't find any file there. So for that, it turns out that you would need to download or git clone another repo, which is R1-Omni's own repo. So I'm just going to, okay, sorry, I just need to put in the git here, HTTP here. Before that HTTP, let me quickly do that. There you go. So let's clear it, and this is where you will find the inference.py. So a bit of the steps, but we just need to follow it accordingly. Hopefully they are going to make it easier in the future. And now from this root repo, you can run this command. So we are calling this that inference.py, and then for this is a video's audio, this is a modality we are giving it. Then this is a model path which we have already downloaded. This is a video path on my local system, and this is a system prompt where we are telling it that as an emotional recognition expert, throughout the video which emotions conveyed by the characters is the most obvious to you. Output the thinking process in these tags and final emotion in this tag. So let me run this. So let's run it here, and there you go. It's very quick. It is just taking around 4 gig of VRAM, and look at the answer. So I'll just show you the video again. This is where I'm just speaking in this microphone and just talking like that. So it says that this is a prompt which I gave it, and then this is a model, and it says that in the video a man in a black gown is sitting in a room in front of a microphone, either talking to someone or doing some recording or podcast. His expression is casual yet passionate, and his voice is firm and polite. These traits suggest a deep engagement and dedication to the conversation or topic at hand, highlighting his passionate involvement. So this is a thinking part which which this R1-Omni has brought to this, and then this is a supervised fine-tuning model. It is telling us it is involved and passion, and then this is another one which looks equally spot on, and then the answer is passionate. So I would say real good stuff. And let's just try one more video. In the next example, I'm just giving it this video which I generated with AI, where this cat is just walking around on top of this hill or mountain or mount. So this is a video which I'm going to give it. Okay, let's see what it does. So I'm just going to first clear the screen here, and then let me run this inference. And there you go. So it says that it is determination. In the video, a cat is on top of a hill, striking a pose with one paw raised. The cat's expression is focused and assertive, indicating determination. Its upright stance and intense gaze suggest readiness and confidence. Yes, spot on. And then same goes for the SFT one. So it says confident, spot on. So look, I believe real good model. Installation is quite hectic. I hope that they improve it down the road. But very small, just 0.5 billion model, you can even run it on CPU. You don't even need a GPU for it. And I think the performance is quite impressive. But let me know, what do you think about it? If you like the content, please consider subscribing to the channel. If you are already subscribed, please share it among your network, as it helps a lot. Thank you for watching.